Hi students, welcome back to this channel. In today's episode, we continue to learn about the sum and the product of words. We'll explore related algebraic operations through examples. In the last episode, we introduced these two formulas. The sum of words is letter B over A. The product of words is C over A. Okay. Before we dive into the examples, let's take a moment to review some prior knowledge. We should have no trouble remembering the first three formulas, but the same might not be true for the others. We'll be writing these formulas as we are recalling them together. Okay. The first one, A plus B square is equal to A square plus 2AB plus B square. A minus B square, all the things are the same except the middle one. Okay, the third one, A plus B, A minus B is A square minus B square. This one is the cube of a binomial. Binomials refers to expressions with only two terms. A plus B cube is A to the power 3 plus 3A square B plus 3AB square plus B cube. Okay, remember this formula, we should keep in mind the patterns of the coefficients and the degrees. The coefficients are 1, 3, 3, 1. Okay, and the degree of A decrease. Okay, while the degree of B increase. Okay, so by the same pattern, we can write down the cube of A minus B. Okay, the only difference is the sign. A cube minus 3. Okay, A going down. Okay, degree become 2B, and then plus 3AB square minus B cube. Practicing for a few times, I think you could remember well of these two formulas. These two formulas are very helpful to expand the cube of a binomial. Okay, let's two are helpful for factorizations. We are going to write down these two formulas while we are remember them. Okay, the first one, the factorizations of the sum of cube. Okay, the factorizations consists of two brackets. Okay, the first one, A plus B. Okay, at the same time, I write down the difference of cubes. A cube minus B cube. Okay, the first bracket, A minus B. Okay, so you see that the sign are the same. Okay, the sign are the same. And the second bracket, A square minus AB plus B square. A square plus AB plus B square. Okay, the same. I think you practice few times, you could remember well these few formulas. Okay, so totally we have 7 formulas. They are very useful in these sessions. Okay, let's move on to the examples. Okay, question 1. If alpha and beta are the roots of the equation, find the values of these few things. Okay, part A and part B are very straightforward. We just recite the formulas. Okay, part A. Alpha plus beta is equal to letter B over A. So letter 3. In part B, alpha beta is C over A. So letter 4. Okay, in part A we got the sum of words is letter 3. Part B the product of root is negative 4. Now we are going to find the value of alpha plus 2 times beta plus 2. It is not difficult. Actually, we can explain the brackets. Alpha beta plus 2 alpha plus 2 beta plus 4. Okay, try to simplify this expression so that we can use the answer in part A and part B. Okay, how do we do that? Alpha beta. Okay, these two terms we have a common factor 2. Okay, so take 2 outside. Alpha plus beta plus 4. The first one, alpha beta, can be found by the answer of part B is negative 4. Alpha plus beta is the sum of roots. According to the answer of A is negative 3. Oh, okay, so we have the answer negative 6. Okay, the last part, alpha square plus beta square. Okay, this expression appear very often, and it requires very special skills. Okay, so perhaps we put a star here. Okay, what is the special technique? Okay, I will show you. Okay, alpha square, beta square. We purposely add 2 alpha beta in the middle. Of course, we cannot add something, but at the end we minus 2 alpha beta. So actually we haven't done anything on that. Okay, plus 2 alpha beta minus 2 alpha beta at the end. Okay, they will cancel themselves. Okay, but once we add the 2 alpha beta in the middle, okay, let's see these 3 terms. It will become alpha plus beta square. Okay, now we copy the last thing in less steps. Okay, if you do that, the first term alpha plus beta square is equal to negative 3 square. Okay, because alpha plus beta is the sum of roots, it is equal to negative 3. Okay, so we have negative 3 square, and the next one is negative 2 alpha beta should be equal to negative 2 times negative 4. Okay, so the answer in this part is 17. So every time you encounter alpha square plus beta square, okay, remember you need to artificially add 2 alpha beta in the middle. Okay, of course you need to subtract 2 alpha beta at the end, and then you need to remember how to continue. Students may find these steps is quite difficult because we need to artificially add something. Okay, it is a very rare situation, but don't worry, I have a trick for you. Okay, let's see the bottom. You can remember this as a formula. A plus b square is equal to a plus b whole square minus 2ab. Okay, can you remember this? Okay, if you do, you can use this formula, jump from the beginning to these steps, so you can avoid, okay, you regard it difficult, you can avoid it and get the same answer. But of course you need to remember some more things. Okay, question 2. Given alpha and beta are the roots of this equation, find the values of the following things. First, we need to write down the sum of roots and the product of roots. Although the question haven't asked us, but they are useful anyway. Okay, in part A, alpha square minus alpha beta but plus beta square. Okay, perhaps we separate into 2 parts. Okay, alpha square plus beta square minus 2ab. Okay, and then you go back to the last page. Okay, can you remember this formula. Okay, a squared plus b squared is whole square minus 2ab. Okay, we use this formula, alpha plus beta minus 2 alpha beta, and the last thing go down. Okay, so combine the last two things. Okay, becomes negative 3 alpha beta. Okay, so we can use the sum of roots and the product of roots. Alpha beta is negative 16. Okay, 25 plus 48, that is 73. Okay, part B. Alpha plus 1 over beta, beta plus 1 over alpha. Okay, we expand the brackets to become 4 terms, alpha beta. Okay, the alpha times 1 over alpha, they cancel, the alpha cancel, so it becomes 1 plus 1 plus 1 over alpha beta. Okay, pay attention that 1 over beta times 1 over alpha become 1 over alpha beta plus 1 over negative 16. Okay, so we have negative 14 minus 1 over 16. So the answer is negative 14 and 1 over 16. Question 3. Alpha and beta are the roots of this equation, and alpha is larger than beta. We remember that first. Okay, in part A, we are going to find the difference of alpha minus beta. Perhaps we put a star here. Once again, we need to use a special skill to solve it. Okay, now to find alpha minus beta, we need to find the square first. Okay, when we have the square of a minus beta square, we have the value of this. We can take the square and we can give the answer of alpha minus beta. Okay, now we try to find this value first. We expand the brackets, alpha square minus 2 alpha beta plus beta square. Okay, and we rewrite them, alpha plus beta square minus 2 alpha beta. Okay, we arrange them in this way because alpha square plus beta square is equal to alpha plus beta square minus 2 alpha beta. Okay, you can substitute them in the place of the underline. Okay, but perhaps some students may not want to use this formula. So perhaps I'll demonstrate one more time how to artificially add things in the middle. Alpha square plus beta square minus 2 alpha beta. We artificially add 2 alpha beta in the middle. Subtract 2 alpha beta in the end. Okay, they can cancel themselves. Okay, in this way we can express the first 3 things as alpha plus beta square. The last 2 terms combine to negative 4 alpha beta. At the beginning, we need to write down the sum of square and the product of square. Sum of square is 4. Alpha beta is negative 3. Okay, so 4 square minus 4 times negative 3. So 16 plus 12 is 28. Okay, so up to this moment, we have the numerical value of alpha minus beta is equal to 28. So alpha minus beta should be equal to positive square root of 28 or negative square root of 28. However, because alpha is bigger than beta, so the negative root 28 should be rejected. Okay, one more thing that is that root 28 can be simplified. Root 4 times root 7. So the final answer is 2 root 7. In part B, we are going to find the value of alpha square minus beta square. It is equal to alpha plus beta times alpha minus beta. Alpha plus beta is equal to 4. Alpha minus beta according to the answer in part A, that is root 2 root 7 by part A. Okay, so we have the answer 8 root 7. Okay, in question 4, this time the two roots of this equation are alpha and 1 over alpha. Okay, find the value of k. Okay, we do the part A first. Okay, the two roots this time are alpha and 1 over alpha. If we use the sum of roots, alpha plus 1 over alpha is equal to k plus 5 over 2. Okay, now this equation is not useful because there are two unknowns. We should use the product roots. Okay, alpha times 1 over alpha is c over a. Okay, so we cancel the alpha. We have the value of k. Okay, we express the answer here. Alpha times, we have the value of k. We can replace k by 2 to update the equations. The equation is equal to 2x squared minus k is 2, so 7x plus 2 is 0. Okay, in part B, we are going to find alpha plus 1 over alpha. Alpha plus 1 over alpha, actually they are the sum of roots. Okay, if they are the sum of roots, the answer is very obvious, should be equal to 7 over 2. C, we are going to find alpha square plus 1 over alpha square. Now in these questions, the two roots are alpha and 1 over alpha. Usually they are alpha and beta. So you can imagine 1 over alpha as beta. They are the same of alpha plus beta square. Okay, if they are in the form of alpha square plus beta square, we can use the formula. We have remembered this formula, right? Okay, so we try to use the same way, but instead we don't have beta, we have 1 over alpha, but we follow the formula is equal to alpha plus 1 over alpha square minus 2 alpha times 1 over alpha. Okay, we just use this formula, but you need to imagine 1 over alpha is beta. Okay, if you do it in this way, okay, the first bracket you can substitute 7 over 2, cancel the alpha. Okay, so we have minus 2, so 49 over 4 minus 2, so we have answer 41 over 4. Part D, we are going to find alpha to the power 4 plus 1 over alpha to the power 4. Now this part actually is quite difficult, but we have part C, so we can learn the technique in part C to apply to this. Okay, how do we do that? Okay, alpha square plus 1 over alpha square. Do exactly the same thing in part C. That is alpha square plus 1 over alpha square minus 2 alpha square times 1 over alpha square. Okay, you try to relate this part and this part. Okay, so the first bracket we have answer in part C, 41 over 4 square minus 2. The final answer is 1649 over 16.